All right, cool. So I'm going to be talking about scaling Laravel. This is scaling Laravel, the talk, as opposed to the video course, which I'm also making with the same name, Scaling Laravel. So you can go to scalinglaravel.com to see information about that. But in the meantime, I have this talk here, and I'll cover, a lot of the content will overlap. It won't be exactly the same. Okay. So what I want to cover here in scaling Laravel is talking about optimization and scaling out. Those are going to be the kind of the two sections of the talk. And optimization and scaling out, you might have heard of the terms horizontal scaling versus vertical scaling. And that kind of relates here. So vertical scaling is sort of like optimization in that if you vertically scale your application, you are generally adding larger servers. You aren't necessarily adding more servers or anything like that. You are just adding more power to your servers. This might be versus scaling out. Scaling out is very similar to horizontally scaling, where you're adding more infrastructure, adding more servers to kind of to distribute your application load amongst many servers instead of just having everything on one. I'm talking about optimization, which has a few more things going on with it. So instead of just saying, just have a bigger server, I'm going to talk about optimizing some certain parts of Laravel and some certain parts of server stuff to help you increase the level of traffic your server can handle. And that's what this red graph is supposed to look at the left. So think of it as like requests per second increasing. Versus scaling out on the right here, we can see kind of a load balance situation where we have a load balancer distributing traffic across other servers, which are themselves hopefully optimized as well. So the question, what is scaling? I'm talking about optimization and scaling out in terms of what scaling is. So optimization, we're going to talk about efficiency. So the goal of optimization is efficiency. So you can think of efficiency as doing less with more, right? So increasing requests per second would be kind of the way to measure efficiency. If your application can handle more requests per second, it is more efficient. So you can do that by increasing the speed of the response, which is the same as reducing response time, decreasing resource usage for the same amounts of traffic. That also is more efficient, even if you aren't actually adding, well, that would allow you to have more traffic to your server. So the secondary goal there is actually also using less servers if you can, which might be a nice feature of optimization as well. Okay, so this is contrasted with scaling out instead of optimization. With scaling out, you're adding more infrastructure, adding more servers to hopefully distribute your traffic and load on your application to many servers. But that doesn't necessarily mean that your application is faster, right? Because optimizations can hopefully make your application faster. But each web request into your Laravel application is going to take as long as it takes. And some things affect that, but adding more servers does not affect that, right? This is about consistency. Adding more servers will keep your application performing at the same level in the face of increasing traffic. So if you have an application where you have like marketing things going on that results in surges of traffic, or if you just have a successful application and it's generally increasing in the level of traffic over time, adding more servers can help stop your application from slowing down. In other words, it keeps the application speed consistent. Okay, so we talked about optimization, we talked about scaling out, and I talked about the goals of each of those. Let's dive into the optimization section. And the optimization section talks about some Laravel stuff and some server stuff, so we'll start in the code. In fact, this is what it covers. So we're going to talk about eager loading with Eloquent, and I'm sure Jonathan Reining is going to talk about that more. I'm just going to talk about this one specific thing, so don't worry, John, I'm not stomping at your feet, I think. Object caching and using the decorator pattern, which is a nice pattern that I like to use in my code to add caching without making my code ugly. PHP-FPM, so this is more on the server side. We'll see how to handle process management in PHP-FPM to handle and allow your server to accept more connections than it would by default. We'll see about configuring OPcache, and I'll actually explain what the settings are in OPcache so you know what's going on with that. And I'll talk a little bit about server specialization, especially in regards to MySQL, AKA your database, but I'll talk about MySQL specifically a bit. Okay, so the N plus problem is the problem that arises if you lazy load, if you don't use eager loading. And the N+1 problem explains when you make an initial query, and then that initial query might return a bunch of data. And if you loop through that data and talk to a relationship, right? So if you loop through some collections, some items that you got back from your first query, and then you make another query for each item, then you have the plus n, right? So the initial query is the +1, and then for every item you get returned back, you have one additional query. So if I have something that returns 10 items and I do another query on each item, I have a total of 11 queries, right? The one query per item in the collection and the first query to get those 10 items. So eager loading helps us prevent this issue. So an example, this is close to how the content is on serviceforhackers.com. I have a topic, so a topic might be like databases or containers or something like that. And each topic has video series, and the series itself has content. So we have my topic model, it has series, and then the class series, the series model has topics, right? It belongs to a topic, and it has content. So it also has, video content. So in my database, let's pretend I have 3 topics. And in my database, I also have 6 video series that are spread out amongst those 3 topics. So maybe each topic has 2 video series, or however that's split up. So if I have a controller where I'm listing out every topic, so this might be like the navigation of Service for Hackers, which actually does something very similar to this. Then I'm going to grab every topic to list it out, right? So I have one query there. But if I also want to show all the series under those topics and maybe even do a little visual display of some of the videos inside of each series, I'll end up with a lot of queries. And we're going to see that here. So if I, had this view topics, this blade view called topics gets the model for topic all, right? So it gets a collection of items of all my topics. And then I'm going to loop through each topic. And for each topic, I'm going to loop through the series in that topic. So I have 3 topics. So I'm going to loop through each topic, and I'm going to get the series. And I'm going to get 3 additional queries because of that, because I haven't done any eager loading. I'm lazy loading. So it doesn't load or run that query until the first time you ask for it. So I'm going to go through each topic, which is 3 queries, because I have 3 topics. And then there are 6 series, and for each series I'm getting content, right? You can see the series and the arrow and content item there. So it's doing a query to get the content for each series. So I have my first query, which grabs all the topics, which is my first query, right? Which is the first time I call, or it's the time I call topics all in my controller. And then for each topic, I'm going to grab the series, and that's 3 additional queries because I have 3 topics. And then for each series, I'm going to grab all the content, and that's 6 queries because there are 6 different series to grab content for. So I have my Laravel debug bar on the bottom here, and you can see it gets the first query to get all topics. Second query gets the first series from that topic, and then it gets all the content for that series. So you can see how this trickles down to creating a lot of queries overall. And in fact, we have 10 queries. All right, so that is when everything is lazy loaded. And if we add eager loading to it, we can see how we can start reducing the number of queries made to the database on this page. Okay, so when you build your relationships into Eloquent, it's very easy to add eager loading. It's so easy, you should really just always be doing it. There's more cases than not when you can and should be eager loading your relationships. Okay, so in this case, well, in general, when you eager load, you're going to reduce n number of queries, however many queries you happen to do, down to 1, because it's eager loading everything in one query. So here I have this with keyword, right? I'm saying the topic, give me all the topics, but also grab the series for those topics. So you can see it in the Laravel debug bar in the bottom here. It's grabbing the topics, and then it's doing one query to grab all the series, right? Because it's a where in query where it's saying grab all series, select star from series where the topic ID is 1, 2, or 3. And I have 3 topics, and that's why there's an ID 1, 2, or 3, and only 3 that is grabbing there. And so that has turned 3 queries to grab each new series for each topic into 1 query. So we are a net of -2 queries, right? We reduced this page by 2 queries for a total of 8, which is okay, but of course it's not great because the content, getting the content for each series is has more queries, right? It has 6 queries. So what we're going to see next is that we're going to reduce 6 queries to 1 query by eager loading. But you may ask yourself, the topic is not directly related to the content, right? The series is in between. So the topic has series and series has content. Can I eager load content off of the topic object? And you can't. There is the concept of nested eager loading in Laravel. So I can say, grab me all topics. And when you're grabbing me that, grab me all the series. And when you're grabbing me that, also grab all the content through the series relationship. So we've done the same thing. We've taken 6 queries and reduced it to 1 query for a net of -5 queries. And overall, we only have 3 queries total from this page from 10. So I actually forgot to show it in the screenshot, but that reduces the time it takes to load the page a lot, right? So eager loading is a very easy way to reduce the number of queries made to the database and speed up your app and fit more requests per second into your server overall. I've run into this issue myself. I'm kind of not paying attention. I just know I need to get some data onto the page. In my Blade template, I just say, okay, I know this model is related to this thing. I'll just grab it. I'm not going to worry about how many queries I'm getting. But the second you turn on your Laravel debug bar and see how many queries you've actually made, you might get really surprised. So eager loading is, I don't know, superb. It's like you should use it. I'm sure there are cases where it doesn't make sense to use it. It always depends on your application and your use case, but it's generally something that you should reach for very early on in your application. I don't really consider it like a premature optimization or anything. Okay, so object caching, otherwise known as how to reduce 3 database queries to 0 database queries. Because in this case, I'm going to cache the result of our queries there and save them in an object cache and then spit that out instead of actually having to query the database for every web request to that page. So object caching can reduce database queries and processing. So never mind database queries. You can cache anything in something like Redis or Memcache or whatever your cache of choice is. So if you have some data that needs processing and that's memory intensive or just takes time, you can cache the results of something and then just show that for some amount of time. So your application doesn't need to regenerate that data for every web request reaching your application. So a naive approach for this is to just throw the cache facade into wherever you want to cache in Laravel. So let's pretend that this is back in my controller code. And I'm just using cache remember, and I'm saying, remember the following stuff. I'm going to give it a cache key of topics. So I'm just going to name it topics, and that cache key should be unique to this thing. And save it for 60 minutes. And the stuff you're going to grab is in this closure here, this anonymous function. So cache remember is going to cache the stuff. If it does not find a item in cache with a name of topics, with a cache key of topics, then it's going to run this function and it's going to grab all our topics. And you can see all I did here is I just grabbed topics with series.content, and I'm grabbing that. That's exactly what we had before, only this time it's getting cached. So the first time someone hits the web page, that stuff will not be cached, and Laravel will therefore ping the database to get the topic and the series content. And the next time, for the next 60 minutes, this will instead of return a recached result of that, so it doesn't talk to the database. So we have our 3 queries, and that goes down to 0 queries. Now, some stuff here, well, I mean, this is fine, especially if this is kind of in the controller. It really depends on how you like to structure your code. I don't like just throwing cache stuff around everywhere. Right, so that can get really messy, especially if it's not in your controller. If it's kind of in your application logic somewhere, you start caching stuff, you end up with issues where debugging becomes hard. And well, I mean, mostly debugging, but also running tests maybe. All that kind of stuff becomes harder because you have this layer of caching, and that could skew the results that you're looking for if you're not wanting a cached result. So if you're in local development, or if you're running into issues with production and you don't know if the cached stuff is what you're seeing as opposed to the real data in the database. So let's see how to structure your code a little bit more to add caching in without, well, with a way that gives you options to disable cache or to do some other stuff to it if you'd like. I like to use what's called the decorator. And over on the right here, we have this gross UML model of the decorator design pattern that for some reason has two interfaces, even though the interface has the exact same method call. The component, a concrete component, an interface decorator, and an interface, or not, and a concrete decorator. And I'll show you a more real example of this rather than looking at a UML diagram, because who cares about that? But decorators let you to add behavior to some base concrete component without necessarily modifying the code of the concrete component. So you're kind of just like wrapping your base object, your concrete component, with modifiers. And you can add the modifiers and remove modifiers as needed. It's very similar to middleware, but not exactly. So you have an interface. The interface is our guarantee that both our decorators and our concrete component has the same method calls available to it. And then you can add decorators to modify stuff, and then the very center, the very end of this chain, or the roots of this nested stuff, we have our roots object, the concrete component. So let's see what that looks like. I'm going to make a repository, and I'm just going to put that in app repo, the namespace, and I have an interface called topic, and my topic interface just guarantees that I have a method called topics, a public function topics. And then we are going to use this interface, we're going to implement it to build back our original behavior where we just grabbed all the topics. So still in the namespace app repo, I have a class called topic query that implements the interface topic. It therefore has the method topics. And here we just throw in that exact same code where my topic model is grabbing all the topics and all the series content. And I renamed it here topic model because the names clashes with the interface name topic. So I just did app topic as topic model as, you know, a way to get around that. So the topic query class gives me back the original behavior where it just grabs the topics. Two things here. On the left, I am using the app service provider, and I'm saying anytime the application sees the topic interface namespace, give me back an instance of that topic query class we just saw. And again, the topic query class is the thing that uses the topic model and grabs all the data from the database. So on the right here, we see that used in the controller where I'm type hinting the topic interface. Laravel sees that and gives me back an instance of topic query because that's what we said to do in the service provider. And then it just returns that to the blade view, and the blade view has exactly what it has before, a collection of topics. And then it scrolls through the topics and it churns through the series of each topic, and each series, you know, gets the content output. So we are back to where we were, right? So what we did here is we added a bunch of code and we were back exactly where we were before, which in some ways is sort of gross, but we'll see why this is also why this also might be a useful feature to add. Okay, so let's add a cache decorator. I have a new class. It's called topic cache. It's in the same namespace, so it's alongside the topic query and the topic interface. Its constructor takes an object also of type topic, also some object that implements the topic interface. So not only does topic cache implement topic interface, it wants an object called next that also implements the topic interface. And this is sort of like middleware. You might be able to see how that sort of looks similar. It implements the interface, so it has a topics method. And this time we're just running cache from member topics, and it's just doing caching. And it's caching whatever the result of this next topics is. It doesn't care if it's a database query or not. It just knows that the next object has a topics method, and it can call that because the interface says it can. So the decorator doesn't care about the behavior of the next thing. And the next thing might be another decorator, or it might be the concrete component, that root object that actually queries the database. In our case, we just have one decorator and one concrete component. So you know, we know that the next object is going to be that topic query object that queries the database. So in this way, you can kind of build up behavior around classes. This is something I was first introduced to in terms of gaming, programming for games, where you could kind of add different behaviors to an object. Like one decorator can make an object spin, another decorator can make it grow larger or something like that. So you can see how you can add behavior to stuff in, you know, some made-up world, some made-up universe of a game. In this case, in PHP, our use case is much more mundane. We're just adding caching to the results of some query without actually editing the class that does the query, right? They're two different classes, they have two different things, and they actually don't care about each other. So it is like a little bit like a Russian nesting doll thing. In the very center, we have the cache topic query class, which is grabbing the topic model and grabbing all the topics and its related data. And outside of that, we wrapped it with a topic cache object, and that's caching the results of the topic query. Although the topic cache class doesn't even know it's talking to a topic query object, it just knows it's talking to something that implements the interface topics. Okay, so back in our service provider, all we need to do is update the service provider and say, return me a new topic cache class. And in that topic cache class, throw in a new topic query class. And that's it. That'll give us a chain of objects that will query the database if it needs to, and cache the result of that, and then return that cached result. So anytime the application sees the interface topic, it's going to return a new topic cache, which in turn has a new topic query inside of it. And all of that behavior will work in kind of this neat fashion of classes that are decoupled with each other and all that good stuff we try to do with our code. And once again, we see our queries are 0 because it's giving us cached stuff. Okay, so you're empowered to do fun things with this. We can add more behavior, like I said. So if you could like filter results differently, or, you know, all sorts of things. Maybe you can add some behavior that's different per user, something like that. I like to create a flag that will disable or enable caches either globally or in specific instances. So in this case, I just have a quicker example. It's like basically a global thing inside of my config for cache, right? So our config directory in the cache.php file, I added a new flag called enabled. And if it's set to false, all I do is return a new topic query object. And if it's not set to false, then I return the topic cache that wraps the topic query object. So if cache is false, it just returns the topic query object, and that does the query itself. Right? There's no caching involved anymore, just by that configuration flag. And that configuration flag can be run off of an environment variable or whatever you need. And like I said, if it's not false, if it's true or anything that's not false, it will cache it. It'll return the topic cache. So you can do fun things with this design pattern. All right, so quick review. What have we talked about? We're talking about optimization. We're talking about on the Laravel side of things mostly. So we have the n+1 problem, which we solved with eager loading, and object caching, which if you use the decorator pattern might give you some nice behaviors and some decoupled code in your application. All right, so more on the server side of things. So optimizing PHP-FPM process management. So two things I want to point out in here. I only highlighted one. This is from the configuration for PHP-FPM, specifically from a file that manages how PHP-FPM spins up processes and handles web requests. The below defaults are based on a server without much resources. We'll forgive them with their bad grammar, whatever to that. But you should know that this is the PHP-FPM that is installed on all of your servers, no matter what the size of your server is, no matter how many gigabytes of RAM or CPU cores it has. The default PHP-FPM configuration is designed for a server with a small amount of resources. So it's worth changing that, even on servers that you think might be small, like a server with 1 or 2 gigabytes of RAM. I think it's still worth changing this a bit. The other sentence in here I want to point out is the second one. This value sets the limit on the number of simultaneous requests that will be served. So the number of processes that PHP-FPM will spin up directly affects the number of simultaneous web requests that PHP-FPM will handle. So increasing this will increase the number of simultaneous requests, and you'll therefore get more requests per second into your server by increasing this. Now I'll show you all the configuration that relates to this, but the process management.maxchildren, pm.maxchildren configuration is the main thing that limits how many requests, or sorry, how many processes are spun up to serve requests in PHP-FPM. Now, each process, so there's multiple processes, right? PHP-FPM spins up multiple processes to handle web requests. Each one can handle one request at a time in serial. So the only way to get parallelism to do more than one request at a time is to have more processes spun up. So this obviously increasing the pm.maxchildren increases the number of requests per second that can get served. But of course, if you have more PHP requests coming in at the same time, then you have more CPU and RAM usage. So you also have to watch out for how much power that is using, how many resources your PHP requests are using. So you should also monitor your server, even if you're just using the built-in top command or installing htop to see how much RAM and CPU is getting used, preferably under real traffic, when there's real traffic on your site. And I'll show you a screenshot of htop in a little bit. So my rule of thumb for deciding what to set that maxchildren set to. So my rule of thumb, I base off of how much RAM is on your server rather than CPU. So the caveat here on the bottom is that you should check your CPU usage after you make changes here as well to make sure you're not hitting a bottleneck on your CPU. So the deal here is that we often have servers that have a lot of stuff on them. So Nginx, PHP-FPM, but also our database, also a cache, also Beanstalk maybe for workers. So you need to take that into account if all that stuff is on your server also. So like a typical Forge server, all that stuff is on one server, right? So they're all competing for resources. So the rule of thumb is how much RAM your server has minus the overhead you want to allocate for the other stuff to run, and divide that by how much RAM per PHP web request. So if we have a 2 GB server and we want to allocate 512 megabytes of that, so a quarter of it, to other stuff on the server, and then we know our PHP-FPM or our PHP web requests might take about 50 megabytes. That gives us about a 30 megabyte limit of the number of processes we want to run on the server. If you have more stuff on the server, especially if you have a MySQL database or any database, you might want to, or you do want to give more overhead, probably half, maybe more. So in that case, that brings it down to 20 max processes because we are allocating half the RAM to overhead and saying the other half can be used for PHP-FPM and Nginx, or PHP-FPM in this case. So that gives us a 20 max processes. So that gives us a value. That gives us a value for maxchildren. And of course, remember, that's based on RAM. So also check your CPU usage after you make changes like that as well. The where, the place, the location to make that change on Debian and Ubuntu servers, which is what we're using on Forge, and what a lot of us are using also, although certainly not all of us, is an etc PHP, and then we have the version of PHP that you're using. So it could be 5 point something, could be 7 point something, the FPM directory, and then we have a pool.d directory where we can put a lot of configuration files and make multiple resource pools, where each resource pool is a set of the settings we see here, the maxchildren, start servers, and all that good stuff. By default, we have a resource pool named www.conf that was set up to serve web requests, usually from Nginx, although it doesn't have to be. Okay, so let's go over what we might want to set here. pm.maxchildren, we already talked about, right? So this value sets the limit on the number of simultaneous requests that will be served. The defaults are based on the server without much resources, but we increased it. So now we are better utilizing, in theory, the resources on our server by allowing a maximum of 30 processes, which will in turn allow 30 simultaneous requests to be run. And that's not necessarily requests per second, because web requests probably take less than a second. So your requests per second will probably in reality be more than 30, hopefully. It completely depends on your application. So the absolute maximum number of processes that will be spun up on this configuration with this configuration is 30. That's a hard limit. At the same time, we have other options though. So the start servers will spin up 5, in our case, processes. So a server in this case, and also children, they're all processes. And each process handles web requests, like I said. So start servers. when the server boots up and PHP-FPM boots up, it will create 5 processes, and they will be idle, and they will be waiting for new requests to come in to handle it. And the reason why the option exists to create processes ahead of time is because creating processes is an expensive operation in Linux in general. It's relatively expensive. It's a little bit slow. It's a little bit, it's a little bit slow, period. So users could notice that time, right? So if you happen to be the first unlucky person to hit a website after PHP-FPM has been rebooted and you don't have any start servers, then PHP-FPM is going to create its first process and serve that web request. And that's a little slower than everyone else who already has processes spun up to start serving requests with. So the start servers just makes that quicker. At the same time, we have spare servers, and we have a minimum and a maximum. So spare servers is the same concept as start servers, except it's not just when PHP-FPM first starts. So if I have 20 requests or 20 processes currently spun up because I have about 20 requests to handle at the same time, PHP-FPM is going to create 4 more just in case there are more requests, right? They're idle and they're just waiting for an overflow of requests, and they'll handle any new requests when, or if and when we end up with more than 20 requests at the same time. That's the minimum. It'll actually try to create up to 8, but it'll do a minimum of 4 as well. But we have that hard limit of 30, right? So if I have 28 processes, it's only going to create 2 new spare servers because there's that hard limit of 30. Even though the minimum spare servers is 4, it's more than that too. And the last item here, max requests 1,000. So the number of requests each child process should execute before respawning. This can be useful for memory leaks and blah, blah, blah. I usually set this to like 500 or 1,000 or so. And it's really a just in case thing. What will happen here is that a process will serve up to 1,000 requests in serial, and then it'll get killed and replaced by a new process. And that'll just hopefully fix any issues of memory leaks, if any were to exist. Here's a screenshot of HTOP. At the top here in the second line, we can see PHP-FPM has a master process, which is started up by user root. You can see the user root is on the far left. And then it has 6 PHP-FPM processes currently running and currently handling requests. Or I think actually we can probably see, if you look at the CPU usage of the PHP-FPM items labeled pool, dub, 2 of them have CPU and memory usage. So, or actually CPU usage. So those are probably 2 handling requests. And then we have the 4 the 4 spare servers. So it has 2 processes currently handling requests and 4 processes that'll spun up as spares. So you can kind of see that in action, that configuration item in action. Now, I had 5 startup servers, but that's only when it starts up, right? After this PHP-FPM starts up and starts starting requests, then the spare servers takes over to determine how many extra processes are idle. We can also see that the processes are owned and run as user data on the far left there, the second column. So if you're wondering, I'm not going to get into it, and I've talked about it in some other talks, but if you're wondering about permissions in Linux, this particular PHP-FPM pool and also the default is to run as user data, so lets the user use permission to write to files and stuff like that. Oh, and on the bottom, apt-get install htop to install htop to use on your servers. I definitely recommend getting it. All right, OPcache. OPcache, I'm running behind. This could be fun. Okay. OPcache is a gimme. It should definitely be enabled. You can see here kind of an old screenshot on fideloper.com. It's reduced my CPU usage a bunch, reduced PHP, the number of milliseconds. Yeah.
One thing, you're good on time, so just don't rush. You're good.
All right, great, perfect. Cool, okay, so PHP is taking a lot less milliseconds to respond after I enable OPcache, which is nice. This is an old screenshot. This is actually a PHP 5.3 or 5.4 server. I think OPcache had a little bit more of an effect. PHP 7 is a bunch faster, but it's still worth having. So when we have a web request for PHP, PHP converts every PHP file, PHP-FPM converts every PHP file it reads into bytecode. that bytecode is what OPcache is caching. So if we cache the results of that, if we cache the bytecode, PHP no longer has to read each PHP file and run it through the interpreter and turn it into bytecode. So we reduce CPU and file I/O by doing that. And we have a small trade-off in RAM and CPU usage, in fact, but it's really small. The gains are greater than that trade-off. So it's a no-brainer. It's really easy to add. So this configuration is in the PHP INI. Notice on the bottom I have the file path there. I'm specifically doing it in the FPM PHP INI configuration. So this is the PHP INI that is used for web requests. I typically don't enable OPcache for CLI run stuff, although you could, and that could help out your workers because workers are usually run on the command line. Okay, so OPcache enabled, the obvious one, enable OPcache. And then we have a few options that are kind of interesting. The first thing is OPcache memory consumption. So the total number of megabytes we're going to allow OPcache to use up. 192 is a decent number of megabytes. You don't need a ton because it's really just caching, not even strings, just caching the bytecode. It's a fairly compressed format of data. Not even necessarily compressed, it's just small. All right, reduce memory usage by caching similar strings with the interned strings buffer. So this is sort of similar to how when we compress text files, how those algorithms work. If it finds the word the 8 times, it's going to have one reference to the word the, and it's going to generate memory pointers to those 8 times that the word the is used. And we're allocating some memory, I think 16 megabytes in this case, to the interned string buffer so that it can cache similar strings in our code, so it doesn't have to use extra memory to cache every instance of very similar code, very similar text. Okay, so max accelerated files. So how many files are we going to cache? 10,000 is a large number. Our Laravel and PHP applications in general do get large because now we have the vendor directory and composer to pull in libraries. It's not as big as node modules, thank God, but it's still gets big. So you want to be able to count how many PHP files roughly that your project has. And I forgot to put I have a one-line command that can do that, but it's basically on Linux, the find command, and then you try to find files that end in .php and then just count the number of results. That's an easy Google search. And you can run that and you can find the number of PHP files in your application and set this number to be higher than that. 10,000 is a high number and it's fine. It's just what I use when I don't feel like or I don't know the number of files in a project. Okay, revalidate frequency and validate timestamps are set to 0 in my case. So I'm telling OPcache not to decide or not to check to see if a file has changed to recache it. So revalidate frequency is a time. It's how often it will check, I think in seconds, to see if a file changed. And then the second option, validate timestamps, is we can tell it to use timestamps to check instead of generating a hash of the file and like using MD5 or whatever it uses and comparing the hash. So by setting that, so why I have set this to 0, why I've disabled that. In this setting, in this configuration, OPcache will never know when a file has been changed. And I like that better because if you think about it, if you upload new code, right? If you deploy new code to your server and it's in OPcache's revalidate frequency is 10 seconds, 5 seconds, even 1 second, you might be serving requests that are old code or even worse, a mix of old and new code because it sees there's some new code, but then the old code hasn't been changed yet in OPcache's eyes. So there's a few seconds there potentially where you have some weird mismatched code. So to get around that issue, you can add to your deployment process a quick reload of PHP-FPM. So I'll show you what that looks like in a little bit. But what I do here is I turn it off so OPcache will never know a file is changed by itself. You have to tell it when to recache. So the last two things here, save comments. So if you're using something like Doctrine that reads the code comments and does stuff off of it, you need to save the comments. I typically don't, so I set this to 0. I won't save the code, or won't save comment strings in the byte cache. And fast shutdown is like this weird gimme, allows for faster calls to deconstructors in PHP code. Turn it on and forget about it. So the caveat I talked about, you must reload PHP-FPM after any code change, after any deployment, in other words, because you're not editing code files in production, right? I definitely have edited code files in production. So in that case, I would edit it and then reload PHP-FPM. And you can see on the very bottom here, sudo service PHP 7.2 or whatever version of PHP you're using, FPM reload, and that'll reload PHP-FPM for you, and it'll tell OPcache to recache the files when you reload it. You don't have to restart it even, you can reload it, which is a faster process that, well, it gracefully restarts PHP-FPM instead of like a hard stop and reboot. Okay, so on the server side of optimization, we've talked about PHP-FPM, and we've talked about OPcache. Versus the code side where we did the n+1 problem and caching, object caching with Redis or Memcache or whatever. So last thing I'm going to talk on the server side of things for optimization, splitting out services, aka creating servers that are specific to the task that they need. And here I also want to mention that giving MySQL its own server is by far the, I don't want to say easiest, but it is like the biggest benefit you can give to your application. If you are not going to load balance, or you don't want to, or you don't feel like you want to manage or have the staff or the know-how to manage your own servers, putting MySQL on its own server is still a gimme, even if you're using Forge and that server has other stuff on it. It's not generating web requests, and just its purpose is only for having MySQL on it and nothing else. It's a benefit. So what you can do is, because the reason you want to do that is to just separate MySQL off to its own server so that MySQL can use all the resources on that server, right? So you're not competing for resources by having everything on one server. Having MySQL on a dedicated server can even let you have multiple different applications using that same MySQL server more efficiently. And if you do that, oftentimes you can even use smaller application servers in trade in place of having a larger MySQL server or whatever your database is. But I tend to use MySQL because I know it best. But specialization in itself, for the same reasons, is a way to scale out your applications, your Laravel applications, because, like I said, you don't compete for resources on your application server, or your application resources plural if you're doing load balancing. So you can give MySQL its own server, and then you can configure that MySQL to use up all the available resources on the server. You can give Redis its own server, so you can do something like get a server that has optimized RAM or just more RAM, and you might not even care about disk space in that case, or CPU really. And you can give workers their own server, and queue workers, which I'll talk about in a little bit. They can have servers that fit the task at hand. So small servers if you're just talking to APIs and it's just network bandwidth. Large servers if you're doing image manipulation or video manipulation, something like that. You can specialize the servers for the task at hand. And to reiterate, even if you're not load balancing or getting any fancier with your infrastructure, you still might want to consider splitting MySQL out to its own server. You'll get a lot of benefit out of that. Now, putting MySQL on its own server is great, but exactly like PHP-FPM, its default configuration is used or set up for a server with a low amount of resources. So one thing that I like to do without having to know every specific detail of MySQL is to just go to the persona tools, that's the wizard here, that generates a MySQL configuration for your server. So you can say things like, I want to have this MySQL in production, it's a dedicated server, it asks what cloud you're on, so AWS versus other clouds, and some other questions, including how much RAM and CPU cores you have, and it'll spit out a configuration for you to use. And there's a bunch of stuff in that configuration, and the important stuff is the caches and limits and the InnoDB section. I, of course, am assuming that you're using InnoDB because that has, or an InnoDB-like storage engine, depending on what flavor of MySQL you use. But anyway, InnoDB has transactional support. MyISAM used to be the default storage engine. It does not have transaction support, but used to have support for full text search. InnoDB now has support for full text search. It is transaction, so it does support transactions. And it's also the default engine now in more modern MySQL, but in general, it's just what you should be using. Okay, so the stuff to pay attention here, these caches and limits and the InnoDB stuff is generated based off of how much RAM you said your server has. In particular, the thing to pay attention to is the InnoDB part. In the very last line here, InnoDB buffer pool size is set on this case to 12 gigabytes. And this is for a server that I set up that I believe had 6. So it's using, what, 3/4 of the amount of RAM it's allocating for the use of the InnoDB buffer pool. This, so MySQL uses the InnoDB buffer pool to do operations on data. It tries to fit data into the buffer pool, then it performs operations on it. And because that's in RAM, it's fast. It doesn't have to read to disk in that case. Because if your data set doesn't fit to disk, then it has to use, if it doesn't fit in RAM, then it has to use disk, and that slows down IO. That slows down a lot because the IO to disk is a lot slower than RAM. So the InnoDB buffer pool should be like 80 to 90% of the available RAM on your server if you have a server dedicated to MySQL. So what you might find is that your RAM usage on your server ends up being really high, and your CPU usage may or may not be. It might not be in this case. And if you might be wondering why your RAM usage is high, but your CPU doesn't seem to be pegged to 100% or anything, that's actually a good sign, because MySQL has used that memory and it's fitting your data into memory in your database and doing the stuff it needs to do, and it's staying performance because it all fits in the buffer pool in RAM. Okay, so use the MySQL, the Persona tool here. It's free. It does make you sign up for an account, which is really stupid, and they will email you stuff, but it ends up being worth it to use the wizard. Okay, so just to review, N+1 problem, object caching. That is on the code side in PHP-FPM, and I forgot OPcache apparently on this slide, but OPcache too. And we split servers out, especially when we talked about MySQL. So that's what we're talking about in optimization. We can talk about scaling out now a bit. And scaling out, like I said, has a focus on, well, we're going to talk about load balancing, and then we're going to see how Laravel reacts with a proxy, such as a load balancer. And we're going to talk about queues. Okay, so load balancing, again, is about spreading traffic across multiple servers. This is about consistency, not speed. Or put another way, it's about keeping your speed consistent. So in that case, it is about speed, but it's consistency of speed, not more speed, not faster requests. Here, with a load balancer, we're adding to our infrastructure, and because of that, it comes with caveats. The caveats, the obvious one is more servers, because we're adding a load balancer and we're adding multiple application servers to the load balancer. But there's everything else too, because we have to decide what to do with all of our ancillary services, our cache, our database, and all those other things we might have running. Okay, so a general idea with load balancing is that you're decentralizing stuff. And part of that is that you have multiple application servers, and those application servers all have to be able to access the common stuff, and that common stuff tends to be state, in other words, data. So anything with state needs to be consistent across all your application servers in general, and therefore all your application servers in general need to be able to access all that state and read the same state as every other application server. So they all need to have the same stuff. So one example is sessions. Sessions by default is a file saved on your server, session data. So the cookie identifies you, and Laravel is able to see that you have a cookie, and the cookie identifies you as, user, developer, or whatever. But that session that relates, that has the session data in it, is still a file on the server by default. If you log into a load balanced application and a session is created on one server, because it'll just be created on one server, and then the load balancer bounces you to a different server, different application server that does not have the session, then this application sees or looks like to the application that you're not logged in, and you get redirected to a login page. So session stuff has to be decentralized. In other words, your applications and all your app servers have to be able to read from the same pool of session data. And typically, what we do in Laravel is just set your session storage to one of your cache drivers. So in Forge, it already has Redis and Memcache by default. You can just set it to one of those and you're all set. And in your other infrastructure, you might dedicate a server to Redis or something like that, and to use as your session storage, and optionally your object cache, right? So session storage, the easy fix is, well, one easy fix is to set session data to be saved in the cookie, so that the cookie identifies you and has the session data, and that only lives in your browser. So that sort of makes it a non-issue, because the server doesn't save session data anywhere. I like to use Redis instead, have a central session store where I would use Redis or Memcache or whatever. And this gets around that issue because all of your application servers can talk to your Redis instance, and they can all have access to the session data specific to each user. So it's the exact same story with user uploads. If someone uploads a profile image and that ends up on one server, then every time they're bounced to a server that does not have that image, then they get a 404. And if they refresh the page and it goes back to the original app server, then maybe the image shows up all of a sudden and then disappears in the next refresh. It gets wonky, right? So a central place to save your files becomes important too. So I use Amazon S3 typically because it's so cheap. You can be a little fancier and set up your own NFS file share. So all the app servers are connected to a network-based file system. So they all have the same files. That's pretty slow, so I don't really like it. S3 I do like. It's fast enough. And it's cheap enough to store those files, and those files are backed up, and you don't really have to worry about deleting them or losing them. Okay, so decentralizing files, decentralizing services. I've talked about Redis in terms of session, but of course, object cache is the other thing you might use your Redis cache for, and that's the same thing. It has state, it has data in it. So all your app servers need to talk to it. So you might decentralize that out to a different server. MySQL we talked about already. I won't talk about that too much other than to say that all your app servers need to talk to the same database. Assuming you don't have some crazy infrastructure that is large, in which case if you do, then hire people because you're probably making a bunch of money, I hope. So MySQL also needs to be on a separate server, essentially. You could decide to put MySQL and Redis and stuff just on one of your application servers to save money on extra servers. That gets pretty wonky because then you have some pets, right? Not cattle. So you have to know what server has what. You have to know that you can't delete a specific application server because it has your database on it. That gets really stressful. Okay, and then the same applies for any other services, especially ones that have state, right? Search engines, workers, cron. So I used to spin up, depending on budget, spin up an extra server that had the single job of just running cron tests. But of course, we just saw in Laravel 5.6 that issue is pretty much resolved by using that with one server helper on your tasks, on your scheduled tasks. So we can just push that project off to Laravel's solution for it. We don't have to have anything dedicated to running crons. We can just say, just run this cron task and only run it and make sure it only runs on one server and be done with it, which is amazing. All right, so let's see a load balancing example, not because HA proxy is amazing or anything, but just because we want to see how load balancers affect Laravel. Although I do like HA proxy, it has some features that Nginx does not have out of the box on the free tiers. Okay, so HA proxy has a concept of front end and back end. The front end accepts connections. So if I go to my web browser and I go to some web page and there's a load balancer, the front end here is the thing that's configured to accept that connection from me, a web browser. So I'm binding in port 80 to listen to HTTP requests, and I'm binding in 443, port 443, to listen for HTTPS requests. I tell HA proxy that that is going to be an SSL connection, and I tell it where the certificate is going to live. HA proxy has one file for a certificate. If you're wondering why it only has one file, the private key and the certificate chain all get added to one file in HA proxy's case, which is really the only thing I've seen that doesn't split it out to different files, but whatever, it works. We can enforce HTTPS. We can say with the redirect keyword, we can say redirect URLs to the scheme HTTPS. So keep the current URI and just add HTTPS to it with a code 301, so a permanent redirect, if this weird thing SSL_FC. So FC is your front end connection, and we're asking it if the front end connection was an SSL connection. If it was not, then redirect it to an SSL connection. And then we have a default backend to the backend we're about to see called BE-scaling Laravel. This is a default backend. You can have multiple backends, and that's how you do something like segment out different websites that have different host names. So if you're using HA proxy to host applications, to serve requests to applications that have multiple applications, and those multiple applications have different domains, as they probably do, then you can sniff out the domain used, the host name used, and use different backends for that. In our case, we're just sending everything to backend scaling Laravel. And here's how we configure the load balancer. I use round robin typically for HTTP applications. Round robin just goes to the next server and the next server and the next server every time it gets a new request. And then we add X forwarded headers. So the Laravel application sees every request as coming from the load balancer. It thinks the web client is not you at your computer on a web browser. It thinks the HTTP client is instead the load balancer because it gets every request from the load balancer. So we add these X forwarded headers to tell the application about the real client. So the first option adds the X forwarded for header. They have a built-in keyword for it, option forward for, and that adds the IP address of the real end user client. And then we can add other headers. I have set header and add header here. I forget why and if that's needed. I think you can use either. But for the HTTP request, we add or set the header X forwarded port, and we set that to the destination port. And the destination port in our case is going to be 443 because it's going to be an SSL connection, because remember we had that redirect to enforce SSL. And then X forwarded proto, also called X forwarded scheme sometimes, is going to be set to HTTP if, once again, the front end connection is an SSL connection. And we're going to know it is an SSL connection because, again, we did that redirect where we enforced HTTPS. So it'll set 3 headers for us to tell us about the client. The last stuff here, it adds an HTTP-based health check. Does a get request to the base URI. It uses HTTP 1.1. It does a new line and it adds a host header to the web requests. You don't need that. I like using that typically when I have a single application. So that'll add a host header and say it's the scalinglaravel.com app. And then we define the servers in the load balancer rotation. I have 2. They're named server 1 and server 2. The name can be anything. It's arbitrary. And we have the IP address and port of our application. Note 2 things. One port, both IP addresses are on a private network. So HA proxy is going to get connected to by the public network, and it's going to talk to our application servers on the private network, which is faster and secure in theory, probably secure. And in fact, HA proxy in this configuration is doing SSL termination. It terminates, it unencrypts the SSL connection when it receives it in the front end. And then it makes HTTP, right, port 80 requests to Laravel. So Laravel, so even though in our web browser we're seeing an SSL connection, the load balancer is talking to our application servers on port 80. And we'll see that that matters in a second. And then we just tell it to use our health checks. We say check every 2 seconds, so that's 2,000 milliseconds. That's an interval. Set the server as healthy after 2 successful health checks. Set the server as failing after 3 unsuccessful health checks, where unsuccessful, because this is an HTTP check, would be like a 400, 500 error. A successful one would be a 200 or 300 response. And the configuration for HA proxy is etc proxy, HA proxy.cfg on most server types. Okay, so why does this matter? The X forwarded header stuff is what's important here in our load balancing configuration. So Laravel, we have to set up to interface to use our proxies to read those X forwarded headers correctly. And a proxy, right, is anything that's in between the web client and your application. So a load balancer is a proxy, a CDN like Cloudflare is a proxy, Varnish, another CDN is a proxy, all that good stuff. Okay, so a few things to note here is I have a page that I made at this demo.scalinglaravel.com app. Demo.scalinglaravel.com has a lock next to it. I'm at this webpage as under an SSL certificate, and the styling is ugly. There's no CSS loaded. All right, so that's thing number 1. The CSS is ugly. It's not loaded. The page is ugly. 2, look at the general information. So this page I made, and what this page does is to ask the Laravel application questions about the client. What it thinks the client IP address is, what it thinks the scheme is, what it thinks the host is, and generate a URL using the URL or the action helper. I forget what I used here in Laravel. But it thinks, like I said, the load balancer is the client, right? That client IP address is a private network IP address beginning in 172.3.1. That's the load balancer's IP. It thinks the scheme is HTTP, not HTTPS, because even though I'm at the website under an SSL certificate, the load balancer is connecting to Laravel under an HTTP connection, not using an SSL certificate. So Laravel thinks it's not an SSL connection. And that's why the page is ugly, because WebKit in this case Safari or Chrome, and I think most other browsers now also, refuse to load content loaded under HTTP when the website is loaded under HTTPS. So the URI generated from my CSS file is HTTP, and therefore it's blocked. This page was not allowed to run insecure content. So that's why it's ugly. Okay, so we have these X-forwarded headers. Why is Laravel not detecting the X-forwarded headers and using that in place of the client information? Because that's what it should be doing. That's what we want it to use, to read X-forwarded headers and say, okay, that's the real client, that's the real protocol, that's the real port being used. We have to tell Laravel to use it, and the way we do that is with a thing called trusted proxies, which is a concept that Symfony has under the hood in the HTTP classes that Laravel uses. So the Symfony HTTP, I think the kernel class, something like that. Laravel comes with a middleware. And in this middleware, you can say what proxies to trust, and you tell it what proxies to trust based on an IP address or multiple IP addresses if you have multiple proxies of the server. So here we have the IP address of the private network of the HA proxy server. It's the private network because that's the server, remember, that Laravel sees. See the client is 172.310.238, and that's therefore what we put here as the proxy to trust. And because we set that as the proxy to trust in this HTTP middleware that comes out of the box with Laravel, this code gets run underneath. This is actually Symfony code, which of course Laravel extends, so it's technically Laravel code also, but the Symfony class has a set trusted proxies method that's on the global request object, and we tell it the proxy to trust, and we tell it to trust specifically the X-forwarded headers because there are other headers you can use also. And if this is configured, then Laravel and Symfony under the hood does what it's supposed to. It uses the X-forwarded headers to fill in the correct client information. And of course, in this case, the important part is that it uses HTTPS instead of HTTP. We no longer get those errors because it's generating URIs correctly. So that'll be important for things like URIs for forms on your website and just building URIs in general. Anytime you use an action helper, a URL helper, a named route helper, all that good stuff. Okay, so that's needed for a few things, right? So on the bottom here, correct URL and form URL or URI generation, and client detection. It needs it to detect the correct client, which matters for things like cookies and CSRF tokens and all that good stuff. CSRF tokens also require that every environment file in your application has the same app key. So if you're load balancing and you have multiple application servers, they all need to have the same app key, that same hashed private key or whatever we want to call it, that's used for encryption in Laravel, so that they encrypt with the same hash and therefore generate matching hashes for things like CSRF tokens and anytime you're using encryption in Laravel. Am I doing okay on time?
Yeah, you could. You're doing okay.
I'll rush through queues.
Maybe a five minutes.
Perfect. Okay.
All right.
5 minutes. It's 1:19. Good luck. Queues. Queues are good because they push work outside of the HTTP lifecycle, so users are not waiting for things to happen during our web request. If you're sending out emails, if you're processing images, all that stuff, you want to push that out of the HTTP web cycle so that you don't have to have users waiting for something to happen and run into timeouts or memory errors that they don't want to see, obviously. A benefit of using queues is that you can scale out workers separately from your front-end web applications, the thing accepting web requests. They can be on different servers completely, and you can scale them out separately. Even if you're on one server, I suggest you use queues because you can use the database queue driver that doesn't require any extra technology. You just set the queue driver as database, you run this migration, that PHP artisan queue table command, and then migrate, and then you have database driver for queues. And then you can set up a worker, which I haven't shown here, but that's documented in the Laravel documentation. You can set up a worker to churn through those queues, which it's just the PHP artisan queue work command, essentially. I like SQS. SQS is so cheap and very scalable and appropriate for most work cases, although there are edge cases where SQS isn't appropriate for, but that depends on specifics of your application. Specifically, if you need like a specific order of jobs to happen, although It can also be in order also nowadays with a newer version of SQS. Whatever. It's cheap. In this example, I have 130,752 requests to Amazon SQS from my shipping Docker course, I think that's from, to send out emails. And the first 1 million is free, so I paid nothing for SQS. Great. I don't have to manage the infrastructure. I don't have to touch it. I don't have to think about it. It just runs. At work at Userscape, we use it more than I do at my shipping Docker course. We made 1.2 million requests last month, and we paid 50 cents. 50 cents, cheap. Okay, so two tricks. Priority is the first queue trick that I like, and you can set up multiple queues and set their priority. So in the last line here, I say what queues to use. I have a high priority queue and a lower priority queue, which is just the arbitrary names. I've just named them high and low priority to make it obvious. Laravel will churn through the high priority queue and will not get to any jobs in the lower priority queue until the high priority queue is empty. So high priority queue gets higher priority. It gets done first. The caveat to that is that if your high priority queue is very busy and constantly getting jobs, the lower priority queue will never get touched. Like trick 2 for that reason, segmentation, create separate queues and have separate queue workers churning through them. So in this case, I'm dispatching a welcome email that goes to the email queue, and I'm saving a gravatar that has some image processing that goes to an image queue. And my configuration is different. So I have supervisor, which is the thing that is monitoring queue workers to make sure that they stay up and running and starts them when the server starts. The top one here will keep the queue worker for emails running. The bottom one here will keep the queue worker for images running, or so email on top, the images in the bottom. And these can be on separate servers, right? These can be scaled out. You can have multiple workers on different servers and scale them out separately. So you can have many servers with processing images if your image queue is really deep or it takes a lot of resources, and maybe just a few servers churning through your email queue, because emails is generally like a web request to an API or an SMTP connection that's relatively quick. And that's segmentation of queues, right? Put workers on server size for their purpose and scale the workers separately. All right, that's it. Was that under 5? 19, 20, 22, 3. That was 4 minutes. Here's what we covered. Who cares? Because you just saw it. You can find more information. Scaleinglaravel.com is the video course I'm making for this. That has more in-depth to this, more in-depth in MySQL, more in-depth in setting up your servers and having them talk to each other, all that stuff. A lot of free stuff at serviceforhackers.com. Find me on Twitter at Fideloper. All right.
Beautiful. Love it. Yeah, that was a lot. Holy cow. But it's all good stuff. That's all the stuff that's scary. Going messing with your PHP-FPM.
I had code. If I didn't have enough time, I had extra code to show you for that stuff.
Well, they have to buy the course if they want the extra code. That's
it. Sure.
All right, thanks, Chris. There's a bunch of questions for you. I'm going to let you go into chat and take a look at those. Most of them, I think, would be maybe more complicated than we could handle right here anyway. So
sounds good.
Go
I
into
like your background.
Check that out. We're Star Wars now, baby. That whole Star Trek is fine, but I'm a Star Wars guy. Thanks a lot. We're going to take a mingle break for 6 minutes. Everybody can stand up for a minute, and we'll be back with Wes.